Hey Kaylin, great question. Let's take a look at an example that I'm just going to make up. Let's pick like a really, really small number. 0, 1, 2, 3, 4, 5, 6. All right, this is a really, really small number. And if I was going to write this kind of in scientific notation or write it with an exponent, I would also write times 10 to the 0 power. 10 to the 0 power always equals 1. Any base to the exponent of 0 always equals 1. It's just a property of exponents. Okay? So if we're going to move this decimal now and put this in scientific notation, if I move it 1, 2 places to the right, so to the right 2 places, what's going to happen? What's going to happen is this exponent is going to change. So it's going to get reduced by 2. Okay, so my answer is going to be 1.23456 times 10 to the negative 2. And if you pump that into the calculator, and again, if you just move the decimal the other way, we kind of come back to where we started at. It would be 0.0123456. So it's kind of like you can remember it as like a property of exponents. When the decimal moves to the right, when the decimal moves right, the exponent gets reduced. That's how I remember it. R gets smaller. And when the decimal moves left, the exponent gets larger. So for most of us, it's pretty easy just to remember that right there. That's the important thing. But here's why. And it's if we just slide the decimal around, and again, most times we would never ever write times 10 to the 0. I mean, why would you? But it's always there. You can imagine it there. And as we move the decimal around, this exponent changes value depending on which direction and how many places the decimal moved. So I hope that helps.